Okay, in this video, we're on to the next section in our chapter on quantifying randomness and probability, and that's looking at conditional probability. So last lesson we looked at independent. This one we're looking at conditional probability, where we look at the probability of something given the occurrence of something else. So basically, one probability is going to give us an effect on the other. It's written like this, as it's shown here. Probability of A, and then there's a line for B. So that's what we say the probability of A given B. So again, in English, what that means is, given that B is true, what is the probability of A happening? So then we can look at the formula for it here, which gives the probability of A given B is equal to the probability of both of them out of the probability of B. So what we're saying again is that both these have to be true, and it's out of this probability rather than out of perhaps the total set that we're looking at. For independent events, the probability of A given B will just be the probability of A because they're independent and they don't affect each other. Similarly, the probability of B given A will just be the probability of B. There's a few more details here. Most of the time, though, when you get conditional probability, it's probably going to be in a tree diagrams question or a Venn diagrams question. And that's the first example. And this will all start to make a bit more sense when we look at it in context. So, example from the book says there are 84 teachers in a school. So that's our universe, right? 84 teachers in school. 56 drink tea. And 37 drink coffee. Now straight away, 37 plus 56 is greater than 84, so we know there's going to be some teachers that drink, tea and coffee. There's also 12 who drink neither tea nor coffee. So that is tea or coffee, so tea union with coffee. Complement will be 12. So we can fill in our Venn diagram here. So our U, and then we've got tea, C, coffee, and tea. The complement of that is 12, so outside we know there's 12. We know 56 drink tea, so all of this is 56, all of this is 37, so this is going to be our unknown. We don't know how many drink tea or coffee. That's going to be our first question. So that's going to be 37 minus the x and 56 minus the x. So what's that going to be? That means that all of these, 37 minus x plus 56 minus x, it's a mouthful, is going to be 93 minus x is going to equal our total minus 12, so 84 minus 12 is going to give us our 72. So x, that middle value there, is going to be 21. So let's put that in and complete our Venn diagram. So 21 tea and coffee drinkers. Coffee is 37 minus 21, so 16. Tea drinkers, 56 minus 21 is going to be 35. And we've then completed our Venn diagram here. So we can start on with the other questions. Question A, as we said, is going to be 21 teachers. Question B, find the probability that she drinks tea and drinks tea but not coffee. So again, if we think about that, probability that she drinks tea but not coffee, so both have to be true. The complement of C in that case. So it's going to be this section here, tea but not coffee, because here she drinks coffee as well. So it's going to be 35 out of the total. And now we're going to get to our conditional probability questions. So it's a slightly different colour. So C. find the probability if she is a tea drinker, she drinks coffee as well. So what's the probability that she drinks coffee given the information that she's a tea drinker? So let's say that probability that she drinks coffee given she's a tea drinker. Okay, so if you think about our formula, it's going to be probability of the intersection over the probability of just tea. So in that case, so again here we're going to look at the probability of both. It's going to be 21 out of the probability that they're a tea drinker, out of 21 plus 35. It's everything in there, so that's going to be 56. And that's it. If you think about that in another way, we're looking at the probability they drink tea is all this. The probability they drink tea and coffee is 21 out of the total. Find the probability that she is a tea drinker and does not drink coffee. So again, we got to think this is similar to this. So it's going to be the probability for D. So the probability that she is not a coffee drinker given she drinks tea. So again, this is going to be very similar. Out of the total tea drinkers, so it's again, because given that, so out of 56, how many do not drink coffee? It's a 35. The other way you might look at it, using this, so it would be the probability that they're a coffee, not a coffee, and a tea drinker, out of the probability that they drink tea. Well, if we worked out the probability of each, what's that going to be? So the probability that not a coffee and tea drinkers, that's this section here, is going to be 35 out of 84 over the probability to drink tea, so that's the total again, 56. And when you work that out, these are going to cancel out, and you're going to be left with 35 over 56. So you can either actually do the probabilities and divide by one by the other, or if you're using a Venn diagram, you can do it this way. I think this is a little bit simpler and visually makes a bit more sense. But if you prefer just to find the probabilities and do the maths and divide it, you'll get the same answer. Okay, so that's example 8. I think that leads on to questions. Yeah, exercise 8H. Sorry, exercise 8H. I'll lead on there. On my pen. So have a look at those, and that's the last part of what we're going to do today. Before we move on to the last section of this unit, which is probability tree diagram. So I've looked at that a little bit already when I was going through independent probability. And everything we've looked at so far, so all the probability stuff, independent, conditional, etc., is kind of, it all tends to get put into context of a Venn diagram or a probability tree question. So once we've done that, we'll have finished that first unit on probability and we'll be done. We get to maybe do a little quiz or something fun like that. Okay, let me know as always if you've got any questions. I'll probably do a couple more examples of some questions from the book and maybe some exam questions too. But yeah, make sure you get in touch if you've got any questions.